Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss the problem asked in today's LeetCode Weekly Contest 463. So let's start with the first problem. So the first problem says you are given two integer array prices and strategy. So the price I is the price of the given stock on the ith day, and the strategy could be of three types. Minus ones means you are buying one unit of stock. 0 means you are holding. To 1 means you have sold it, right? And you are also given integer k, and you can perform at most one modification in this strategy, and the modification can be select k consecutive elements in this strategy. The first, like, change the first k by 2 elements to 0 and change the last k by 2 elements to 1, and the profit is defined as the sum of strategy into price across all the days, right? And return the maximum possible profit you can achieve. So this is a pretty much implementation problem, I would say. So it's a like this problem can be solved using prefix and suffix sum concept. So let's see how we can approach it. So in the first problem, it says that the profit is defined as the sum of strategy of I into prices of I, right, across all days. So what I'll be doing, I'll first create two prefix array. One would be prefix of I, and one would be prefix prices of I. So prefix of I is essentially summation of strategy of I into prices of I across from 0 to I, and prefix prices of I equals to uh, the the prefix sum of all the prices of I from 0 to I, right? So now let's consider you have taken this k consecutive strategies, and you want to apply the operation, right? We can do the operation at most one. So in what we do in the operation, we, like, in the first half, like, we convert all the strategies in the first half to 0, and we convert all the strategy in the second half to 1, right? So in this case, what would be your answer? Like, what would be the total cost? Total cost will be the prefix sum of this part plus prefix sum of this part plus the prefix prices sum of this part. Is it right? Because once all become ones, it would be, I mean, the strategy into, since the strategy is one, like, you just have to configure the prices, right? Because this is already one, and for this is already 0. So the contribution of this part would be 0. The contribution of this part would be sum of the prefix prices. So your cost would be, let's say, this is your current index I. So this will be I minus k minus 1. This is your this index, and this particular index, I mean, just left of the boundary would be I minus k, right? So your cost would be, so we know that the cost would be this plus prefix prices sum of this. So to calculate this part, this is the last index n minus 1. Cost would be PRE of n minus 1. We know that for the sum of L2R, like, if you calculate the prefix sum, the sum of L2R would be prefix of R minus prefix of L minus 1, right? The prefix sum of L minus 1, right? So that's exactly what I'm doing here. Look, this sum would be prefix sum of n minus 1 minus PRE of prefix sum of I, right? This is this part plus, now let's come to this part. This is your initial index 0. This will be prefix sum of, this is your I minus k, right? I minus k. This is the sum of this part plus the last part, this. So its sum would be one thing, this is I, then what would be this index? This index will be I minus k by 2 minus 1, and just left of the boundary, this would be I minus k by 2, right? So this will be prefix prices sum, prefix prices of I minus prefix prices of I minus k by 2, right? So yeah, this is all about the sum, and we can similarly calculate for each possible uh, contiguous subarray of size k in the given array, right? And we can just check which one is giving the maximum value of this, right? So yeah, this will be your answer. So let's see how we can write code for it. This is the code of first problem. I would highly recommend to check out the explanation part first, right? Because I'm exactly doing what I have explained. So this is my prefix array. This is my prefix prices array. So prefix array essentially calculate the sums of prices of I into a strategy of I, and prefix prices essentially contains the sum of prices of I. So this is the standard calculation of the prefix array. So prefix 0 would be strategy of 0 into prices of 0, and for I equals to 1 to n, your prefix I would be prefix of I minus 1 plus strategy of I into prices of I. Similarly, prefix prices of I calculation, so prefix prices of 0 equals to prices of 0, and for I from 1 to n, prefix prices of I equals to prefix prices of I minus 1 plus prices of I. So once you calculate these two prefix arrays, now your answer, initially your answer would be, so for there one point, you may or may not do the operation, right? So if you don't do operation, what would be your answer? Your answer would be prefix of n minus 1 without doing any kind of operations to change. Like the operation was to choose a contiguous subarray of size k, and then change the first half strategy to 0 and the second half strategy to 1. So if you're not doing anything at all, your answer would be standard prefix of n minus 1. Now if you want to choose the contiguous subarray of size k, what we can do, we can go through all possible contiguous arrays of size k, and we can apply the operation. So I'm starting from I equals to k minus 1 to n. So please check out the explanation part. I have explained how to calculate the cost now. So your cost would be prefix of n minus 1 minus prefix of I. So this is the sum of the right part of the contiguous array. Then this is the sum of the left part of the contiguous array, and this is the sum of the value which we can get from that contiguous part. And at the end, just check your answer is equal to max of answer comma cost, and return your answer. So yeah, this is all about the code of first problem. Now let's look at the second problem. This is the second problem asked in today's contest. So it says you are given integer array nums of size n and a 2D array query, where each query consists of 4 information: left index, right index, k and v, right? And for each query you have to apply the following operation. You start with the left index, go until right index, and go with the jump of k, so idx plus equals to k. Now at each index, like the number present at the current index, just multiply that with vi and take a modulo, right? And you have to return the bitwise of all the elements after processing all the queries. So if you notice here, your the length of the queries could be 10 to the power 3, right? And the size of the array is also 10 to the power 3. So you can simply apply a brute force solution. So the complexity would be like, brute force means just do exactly what it is saying, the problem statement saying, and it would be accepted, because 10 into 3, like for 10 to the power 3, 10 to the power 3 would be 10 to the power 6. That can easily be accepted. So let's directly look at the code. It's pretty straightforward implementation. So what I have taken, this is my mod. I'm going through all the queries. This is my left index, right index, k and v. This is my index. Initially it would be the left index. Now I'm going till r. I have updated my nums of index. That would be nums of index into v. I have multiplied v and I have taken the modulo, and I am going through the jump of k, idx plus equals to k, right? And this is my answer. Then at the end you just take the XOR of all the numbers and return your answer. So the complexity of this code is order of n into q, and both are up to 10 to the power 3, so both can easily be accepted. So yeah, this is all about the code of second problem. Now let's look at the third problem. In the third problem, you are given an integer array nums and integer k. You may repeatedly choose a contiguous subarray of nums whose sum is divisible by k. Means choose a contiguous subarray whose sum is divisible by k and delete it, right? And after each deletion, the remaining elements closes the gap. I mean, just remove the element and now you would get a new array, kind of. For example, 3 1 4 and 5. Let's say you remove 1 4 and 5, so now the array become 3 and 5, right? And you have to return the minimum possible sum of nums after performing any number of such deletions, right? So yeah, this is a dynamic programming problem. So I'll try to find a DP array where DP. So see, we have to find out the minimum possible sum after performing the deletion, but I'll calculate a DP which essentially find the maximum possible sum, which maximum possible sum which you can get of that deleted number, and ultimately your answer would be total sum minus the DP of n, right? I'll explain how to approach this problem. To approach the third problem, what we will do, we will first calculate the prefix array. So prefix of I equals to summation of all the numbers from 0 to I, right? We will first pre-compute the prefix sum. And one interesting point in this problem, that let's say you want to find a subarray whose sum is divisible by k, right? You want to check if whose sum is divisible by k. So instead of going through all possible subarrays, what you can do, you can calculate the prefix sum, right? The prefix sum of all the numbers 0 1 2 3 4 and minus 1. So I claim that, let's say the prefix sum of I to j is divisible by k. If it is given that the prefix sum of I to like all the numbers from index I to j is divisible by k, alternatively, so what will be the prefix sum? So what will be the sum of these numbers? The sum will be prefix of j minus prefix of I minus 1, right? Prefix of I minus 1. So from prefix of j, just subtract prefix of j I minus 1. Like you would end up getting the sum of all the numbers from index I to j. If it is given that this is divisible by k, right? So so we know that a minus b modulo k equals to 0 means a modulo k equals to b modulo k. So similarly here, it means prefix of I minus 1 modulo k equals to prefix of j modulo k, right? This is a very interesting property. Means that if you want to find a contiguous subarray whose sum is divisible by k or not, just check if your prefix of I minus 1 modulo k is equal to prefix of j modulo k, right? So this was a very interesting and important point in this problem. So we know that prefix of j modulo k must be equals to prefix of I minus 1 modulo k, right? So what we can do now to calculate, so this is the definition of my DP, what DP of I says. So DP of I is equal to max sum of all the deleted numbers possible from index 0 to I, right? Because you want to delete few contiguous subarrays, right, whose sum is divisible by k. So after so DP of I contains the maximum sum of those deleted numbers. So let's see how we can calculate DP of I. So DP of I equals to, there are two possibilities. Either you want to delete this number or not. If you don't want to delete this number, your DP of I would be DP of I minus 1. So here, don't delete ith index number, right? Now if you want to delete it, what you have to do, you have to find a find an index j such that we know that the sum of all these number will be divisible by k, means this like prefix I modulo k must be equal to prefix j modulo k. So let's say this is your j, and such that prefix of j modulo k equals to prefix of I modulo k, right? Let's say this is one of the j. What it means? It means that the sum from index j plus 1 till I are divisible by k, right? Can I say if my prefix of j modulo k equals to prefix of I modulo k, it means that all the numbers from the sum of all the numbers from index j plus 1 to I are divisible by k, right? So here now we want to delete this number, right? So what would be dp of I? Dp of I can be, what is my dp of j? Dp of j plus dp of j plus prefix sum of I minus prefix sum of j, right? So this prefix of I minus prefix of j, what it means? So the sum of this number is divisible by k, right? So what will be the sum? The sum of these numbers are exactly prefix of I minus prefix of j, the previous, right? We know that for sum L to R, the sum is equal to prefix of R minus prefix of L minus 1, right? So for the sum from j plus 1 to I, your sum would be prefix of I minus prefix of j, and this dp of j is the again the maximum possible sum which you can get from at index j. But here interesting point is that this j can be multiples, right? J can be, I mean, maybe there are 5 j's whose modulo is exactly same as I. So we have to find out the best of them, right? So we have to find out the best of among all these indexes as j. So well, you can just reform it and you can write it prefix of I plus, see this prefix of I is it's constant, right? This is common for all the j's. So can I write prefix of I plus give me the best of dp of j minus prefix of j? Can I say that? Yes, I can, because prefix of I is anyway common. So your dp of, so if you don't want to delete it, your dp of I would be dp of I minus 1. If you want to delete it, your dp of I would be prefix of I plus best among dp of, I mean the best value, the best means the max, because I am only considering on the max deleted part. So give me the best and maximum possible value of dp of j minus prefix of j, right? So, and at the end, what would be your answer? Your answer will be total sum. Total sum is prefix of n minus 1. This is my total sum minus dp of n minus 1, right? Prefix of n minus 1 is total sum. Dp of n minus 1 is the maximum sum which we can get from all the related number from index 0 to n minus 1. So this will be your answer. So yeah, let's see how we can write code for it. This is the code of third problem. You are given nums and k. This is my size. This is the prefix array calculation. So one thing, I have taken one base indexing in the coding part, but the approach is exactly the same how I have discussed in the explanation part. No difference at all. So this is the the prefix array calculation. Prefix 0 equals to 0. Now for index I2 and prefix of I equals to the previous prefix sum plus the current number. Now this is my best array, this is my dp array. So dp of I, we know dp of I contains the maximum sum of all the deleted number possible from index 0 to I. Now this is my best, because we have to find out the best among, the best means maximum among dp of j minus prefix of j. So initially the best of 0 equals to 0. The corner case, let's say there is no element, you don't want to take any element. So the sum would be 0, so the modulo of k equals to 0. So this is the corner case. Now I'm going through from index I equals to 1 to n. This is my m, the prefix of I modulo k. So this is the case when you don't want to delete this number. So in this case dp of I would be dp of I minus 1. Now if you want to delete the number, find the best value. Find the best value of dp of j minus prefix of j, right? So prefix of j, right? And so just check if your best of m, this m should be exactly the same, because we have to find out the best among all those number whose modulo are matching with the current modulo, prefix of I modulo k. And right, so like we can't just go and check with all the numbers. We have to check only those numbers whose modulo is same as me. So this is my current m, which is prefix of I modulo k. I want to find the best among those m's, those indexes who have the same modulo with k, right? So if the best of m is not equals to minus infinity, because initially I have taken as minus infinity to all the numbers. If you get a number, then dp of I equals to max of dp of I comma prefix of I plus best of m. This prefix of I plus best of m, right? The best of m. And just update your best of m which will be the maximum of best of m, comma, like best m so far, comma dp of I minus pr of I. So we have to update the dp of I minus pr, the prefix sum of I, and at the end what would be your answer? Your answer will be total sum minus maximum sum we can get. So this will be the minimum possible sum which we can get for the non-deleted numbers. So yeah, this is all about the third problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.